Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find area of the green shaded circle? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. We have a circle with a vertical chord AB and a horizontal chord CD that cross at the inside point E. To find the circle's area, we only need its radius, so every step from here aims at the radius r. Chord AB is vertical and chord CD is horizontal, so they meet at a right angle at E. That clean right angle lets us treat horizontal and vertical distances completely separately later on. Along the vertical chord, segment AE is 3 and segment EB is 4. Along the horizontal chord, segment CE is 2. Those three lengths are everything we are given. The fourth piece, segment ED, is not labeled yet. We need it to know the full horizontal chord, so finding segment ED is our very first goal. Our first insight is this. Intersecting chords find the missing chord piece. Substitute the known lengths into that rule. On the left, segment AE times segment EB is 3 times 4. On the right, segment CE times segment ED is 2 times segment ED. Now it is just algebra. 3 times 4 is 12, so the equation becomes 12 equals 2 times segment ED. We are one division away from the answer. Divide both sides by 2. Segment ED equals 12 over 2, which is 6. The missing horizontal piece is now known. Add the two vertical pieces. Segment AB equals segment AE plus segment EB, 3 plus 4, which is 7. That is the whole vertical chord. Add the two horizontal pieces. Segment CD equals segment CE plus segment ED, 2 plus 6, which is 8. Both chords are now fully known. A faster route is the perpendicular chord's radius identity. 4r squared equals the sum of the squares of the four chord pieces. A key fact, the perpendicular from the center to any chord passes through the chord's midpoint. So O sits on the perpendicular bisector of segment AB and also on the perpendicular bisector of segment CD. Now we build. Drop a perpendicular from the center O straight to the left onto the vertical chord AB and mark its foot M. The little square at M shows this meeting is a right angle, and M is the midpoint of segment AB. Trace the segment from M across to B. Since M is the midpoint of a chord of length 7, the piece from M to B is half of 7, which is 7 over 2. In the same way, draw the perpendicular from O across to the horizontal chord CD and mark its foot N. Again, a right angle sits at N, and N is the midpoint of segment CD. Because N is the midpoint of segment CD, the center's horizontal position is exactly halfway between C and D. We now compare that position to the crossing point E to see how far O sits to the left of the vertical chord. The midpoint of segment CD lies to the left of E by half of segment ED minus segment CE. That is 6 minus 2 over 2, which is 2. So the center is 2 units to the left of E. The vertical chord AB runs right through E, so O sits 2 units to the left of segment AB as well. That fixes the horizontal leg segment OM at 2. Draw the radius from O out to the rim point B. Together with segment OM and segment MB, this closes a right triangle, right-angled at M, and its hypotenuse segment OB is exactly the radius. Substitute the four chord pieces. 3 squared plus 4 squared plus 2 squared plus 6 squared is 65. Divide by 4. so r squared is 65 over 4. For a proof outline, center to chord perpendiculars bisect each chord. Express 4r squared as the square of the whole first chord plus the square of the difference on the perpendicular chord. After expansion, the cross terms cancel because intersecting chords give segment AE times segment EB equals segment CE times segment ED. The circle's area is pi times the radius squared. With the radius squared equal to 65 over 4, the area of the green circle is 65 pi over 4. The answer is 65 pi over 4. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.